Hello scholars, welcome back to the Kemet Maasai Academy. Today we're looking at rotation. What do we mean when we talk about rotation? So to rotate something is to really turn it. So we call the point that the object is turning on, we call that the axis of rotation, right? So it's like you have a point and then the object is just moving around that point, around it, pivoting on that axis of rotation, the axis of, so this should be the axis of rotation. Alright, and the new drawing, after I rotate it, the new drawing is called the image. Alright, so what I'm going to do, I'm actually going to rotate each of these objects. I'm going to rotate them. So remember, we have a 90 degrees. So this is 90 degrees. From north, 90 degrees. A straight line is 180 degrees. And then 90 more on that would take it to 270 degrees. And all the way back around, it would be a full 360 degrees, right? So I'm going to rotate each object 90 degrees, 180 degrees, 270 degrees, and you know that 360 would take it back to the original object. That's what I'm going to do for each of those. In a rotation, the size of the object remains the same. So the object and the image, same size, but what really changes in the rotation is the orientation of the image. So depending on which angle we're rotating it to, whether it's a 90-degree rotation, 180, which would be a straight line down from the original, the orientation will be different. So let's see how the orientations vary. So if we're rotating this arrow, so this is the original arrow, this is the object. If we're rotating it 90 degrees, so remember 90 degrees, this is a 90-degree angle, right? So it would actually now look this way. That's a 90-degree rotation. It forms a right angle. See that? Perpendicular. So the image is perpendicular to the object under a 90-degree rotation. So this circle here is acting as our point, our axis of rotation. If we rotate it 180 degrees, remember 180 degrees is a straight line. So that would be straight down from the origin. This is a 180 degree. It's another 90 degree. So 90 degree rotation, a full 180 degree, 290 degrees. And if we were to rotate this object 270 degrees, that's another 90 degree, it would take it here. Okay? So this is a 90 degree rotation, 180 degree rotation from the origin, from the object, and this is a 270 degree rotation clockwise. Now that's the thing with rotation. If we're rotating it clockwise, we're going in the direction that the hands of the clock go. If we're rotating it anti-clockwise, we go this way. Therefore, if we had started here and we're rotating anti-clockwise 90 degrees, this would be the anti-clockwise 90 degrees. The 180 would be the same either way, and this would become the 270 degrees anti-clockwise. Alright, so let's rotate this clockwise 90 degrees, so that's our 90 degree angle. clockwise, 90 degree. If it was anti-clockwise, the 90 degree would be over here, that way. 180 degrees straight down from the origin, straight line, 180 degrees. This would be a 270 degree rotation clockwise. From here, all the way around to here, that's 270 degrees clockwise. See that? So 90 degree rotation, 180 degree rotation, 270 degrees rotation. How about the letter B? Alright, so let's rotate the letter B 90 degrees. So now it would turn down like that. That's a 90 degree rotation. 180 degree, how would it turn? Clockwise, that would be the B. You notice the orientation of the B? So here it's turned to the right in the original, in the object. Here it's turned down. Here it's turned to the left. And if we rotate the B 270 degrees, it's going to turn up. Interesting how the orientation of objects change depending on the degree that we are rotating them, right? Alright, how about the crown? Alright, because of the shape of the crown, it's actually going to overlap. If we rotate in this 90 degrees, it's going to overlap like that. See, it's kind of overlapping clockwise. Again, we're going to have some overlap. That's the 180 degrees. And for the 270 degrees, that's our overlap. So because the axis of symmetry is so narrow in here, the images and the objects overlap, but that's fine. Sometimes the image overlaps with the object if the axis of symmetry is pretty close to the end of the object, right? But like where we had lines actually stemming out, then it's not so, they won't overlap. So here we have a flag. It's oriented to the right. So if we rotate it 90 degrees clockwise, so in the direction that the hands of the clock would go, so here we have, so it will look that way. See that? See, it forms a right angle right there, 90 degrees. 180 would be straight down, but the flag would turn that way. Notice it was oriented to the right, now it's down, now it's oriented to the left. So what's going to happen to it under a 270 degree rotation? Another 90 degrees, so it's going to be up. And you know, a full 360 degrees would take it back up to the original. So that's all the way, a complete rotation, a complete revolution too, would take it from the origin, from the object, so that's 90 degrees, 180 degrees, 270 degrees, a full 360 degrees back to the origin. And those are the basic degree measurements that we need to know for rotation at this level. Higher up, you'd actually get your protractor. Any degree, whether it's a 45 degree, 70 degree rotation, 60 degree rotation, you'd actually take your protractor and measure along the line, get that angle, and then draw your new image. But we can easily use these because we know that's 90 degrees, 180, 270, 360, right? Our 4 quadrants. Alright, so the last one, so let's rotate this. This is 90 degrees. It's going to be oriented this way. 180 oriented that way. See the difference in the orientation? So that's up. Clockwise 90 degrees, that is now to the right. Clockwise 180, now it's down. And continuing clockwise 270, it's now to the left. If we're going anti-clockwise, so from the origin, from the object, anti-clockwise, so that would have been 90 degrees anti-clockwise, 180 degrees anti-clockwise. So the 180 is the same whether it's clockwise or anti-clockwise, straight down from the origin. This would have been 270 degrees anti-clockwise. 360 is the same because it's just going back to the origin, all the way around and back. 360 degrees, a complete revolution. Alright, so that's it for rotation. More technicalities as you go further up. You'd have to actually get your instruments in and do your calculation, your measurements and so on. But basically these are the concepts for rotation. Alright, so if you have been helped by this video, just drop a line in the comments to say thank you, miss, and just share the video with as many students as you can so that we all can benefit and progress in our study of mathematics. If you have not yet subscribed to the channel, please do so, and let me know if you want me to do videos on any particular topic. I'll gladly do that for you. So scholars, thank you for joining me. Keep practicing your math, and I'll see you in the next video.